Okay, hey everyone, nice to see you guys all in here. So before we get into um, Goodman's new riddle of induction, I want to just make sure we're crystal clear on Hume's problem of induction. So let me just do a little quick recap of that, and then I will either pause the video or start a new video where we'll talk about the new riddle, because Nelson Goodman's new riddle of induction does build upon Hume's problem of induction. Now, remember, what's induction? So first of all, human beings, we're these special creatures that can reason about the world. We can know things about the world. Isn't that interesting and trippy? Like, think about it like this. If us human beings didn't exist, or if no intelligent life existed, the universe would never be able to reflect or contemplate about itself. So our brains give us the ability to understand things about this universe we're in. Now, the way we come to understand things is through reason, and there's two general forms of reasoning: deductive reasoning and inductive reasoning. In this class, we focus on inductive reasoning since that is the type of reasoning we utilize in science for the most part. Um, of course, we're always kind of using both, but science is characterized by induction. Now, what is this method of reasoning called induction? Induction is a method of reasoning where we make generalizations or predictions about the world, um, about the world based on past observation. So we either observe something over and over again and make a generalization that this must be a fact. So we observe over and over again that when we combine two hydrogen and one oxygen molecule, we get a substance like water. And by doing this over and over again, we come to some generalization that H2O creates the substance called water that we need to exist. Um, Another way induction works is like uh, instead of the conclusion that we come to being a generalization, the conclusion that we come to can be a prediction, right? So I observe something over and over and over and over again, and I notice that these two things, happen together over and over and over again. So, every time I eat, this is kind of like Hume's example, every time I eat moldy bread, I get sick. Every time I eat moldy bread. So let's say I eat moldy bread 5,000 times, and each single time I throw up. Well, now here's a prediction I can make based on induction. The next time I eat moldy bread, I'm probably going to get sick. I'm probably going to throw up. Okay? So now this method of reasoning called induction is exactly how is the exact reasoning we use in science, because in science we observe the world over and over again. We find some patterns, we find how things are connected, and we either generalize, we either assume that this is just some fact about the world, or we make a prediction based on that observation. Okay? Now, what Hume asks is, what justifies this method of reasoning called induction? So, like, why is it so reliable? Why is it the case that when we observe something over and over again, it gives us evidence to assume that that thing that we keep observing either is some general feature of the world, or is something that we should expect to see in the future? Um, let's focus on the prediction part, because that I think makes the problem clearer to describe. So again, say I observe the sunrise every morning, at 5 a.m. for thousands and thousands of times. And so I come to predict, okay, tomorrow morning, Thursday, July 3rd, when I wake up at 5 a.m., the sun will rise once again. Why? What's my justification? the fact that I saw it rise at 5 a.m. 5,000 times in the past. Now, the problem here is we don't know for certain just because I have observed the sun rise these 5,000 times in the past that it will in fact rise tomorrow morning. We don't know this with complete certainty. So far so good. Because we don't know for sure that the future will conform to the past, that the future will be like the past. We have to just assume this. So us poor, small-brained human beings, we can't see into the future. And so, for all we know, tomorrow the sun won't rise; it'll explode, or I don't know, the Earth will explode, or something will happen. So we can't say with complete certainty, based on all my past observations, that the sun will in fact rise tomorrow morning. We just have to brutally assume that the universe is structured, it's orderly, such that the future will conform or will be similar to the past. That if I'll keep dropping this marker and I'll keep hitting the ground, if I did this thousands and thousands of times, and the next time I do it, it will again hit the ground and not randomly turn into a chicken. Now, again, you might think, well, obviously it won't randomly turn into a chicken. But the whole point is, how do we know this? We don't know what the future's like. We can't look into the future. We don't know for sure that the same physical laws that have held, in our universe across these billions of years, that those same physical laws will continue to hold in 5 minutes. We don't have insight into the future. But nevertheless, we use this method of inquiry called induction to make predictions about the future. And we happen to do it quite reliably. So now notice that is how science works. We can predict with, using Einstein's, for instance, Einstein was able to predict with complete accuracy, perfect accuracy, to down to the second of when a solar eclipse would happen, 100 years into the future. That's pretty. That's like a pretty amazing feature of science, the precision of the predictions that we can make, and then we see them actually happen. Okay, but the problem is that we don't know for sure, and so we have to just brutally assume. We just have to have faith that the future will be like the past. And this is what Hume calls the uniformity principle. So now tying this back to the reading, the assumption behind science that the universe is orderly and predictable such that the future will conform to the past, that is what Hume calls the uniformity principle. And here I have it written down. So Hume's uniformity principle, we assume that the future will resemble the past, and the problem is we can never prove it. We just assume this. Okay, we have to just brutally assume this. Why can't we prove it? Because if we try to prove that the future will be like the past, the only type of argument that we can give is an inductive one. So the only thing I can say is something like this. I know that the sun will rise tomorrow morning. Why? Because relative to every point in the past, when you've asked me, hey, Alicia, is the sun going to rise tomorrow morning? And I've said, yes. What have I noticed? I noticed after the fact that the sun did in fact rise, right? So relative to my past, every time that you've asked me about making a prediction about the future, my prediction ended up being correct. And you might think that that serves as evidence to show that this method of inquiry called induction works. That, yeah, noticing a pattern over and over again, the more times we notice it, the more times we notice some systematic pattern in the universe, the more likely it will continue to hold in the future. But again, we don't know for sure that the future will be like the past. And so we just have to brutally assume this. And therefore, there is no argument we can give for the reliability of induction without making use of induction. And that is what we call a circular argument. And circular arguments are never explicative because what you're trying to prove is assuming the truth of what you're trying to prove. So let's say here would be a circular argument. I tell you, capital punishment is unethical. And you ask me why. Why is it unethical, professor? And I tell you, capital punishment is unethical because, reason, it is wrong for the state to kill a person for committing a crime. Notice that that's a circular argument because the reason I state, the premise, the reason for why I come to the conclusion that capital punishment is wrong is just a restatement of the premise or the reason. So it is wrong for the state to kill people for committing crimes, therefore capital punishment is wrong. Those two sentences are saying the exact same thing. And so you're not giving me any new evidence. You're not giving me an illuminating argument that convinces me why capital punishment is wrong. And the same thing is going on here. When we try to justify the reliability of this method of reasoning called induction, all we can say is that induction has worked thus far. Like, yeah, it's been able to make correct predictions so far. But now notice, we're just saying something like this: induction works, or it's a reliable method of getting knowledge about the world because it's always worked. But that's not a new illuminating reason. You can't say it works just because it works. That's circular. Okay, so there's our little review of Hume's problem of induction. Now, along the way, what we noticed is to get away from these puzzles, scientists make certain just assumptions about the universe, because Hume's problem of induction is a puzzle we can't solve. So now here's something that scientists just brutally assume. They brutally assume that we live in an orderly and predictable universe such that the future will be like the past. For all practical purposes, we can expect the future to conform to the past, for it to be similar to what the past is like. Okay? So I just brutally assume that tomorrow, when I drop this pen once again, it will fall and hit the ground and not turn into a chicken. It's just an assumption I have to make. I don't know for sure, right? For all I know, the laws of physics might change when I wake up tomorrow, but I just assume that it is the case. So as we talked about Hume's problem of induction, what we also come to notice is there are certain assumptions scientists make, and they're called assumptions because there's no argument, there's no justification, there's no evidence that we could possibly give to prove or establish this assumption. We just have to have faith that this is true. And so here's one assumption we talked about now. So assumption. I'll just put assumption 1. It's Hume's uniformity principle. And it's what I just had up on the board. That we live in an orderly and predictable universe such that the future will be like the past. So our scientific predictions, we can trust them for all practical purposes because we assume, for all practical purposes, tomorrow, for the most part, physically, biologically, chemically, will be like today. Okay? It's an assumption that we make as scientists. We brutally assume it. Now, another assumption I want to mention that we make as scientists is the assumption of simplicity. And the reason why I am telling you this now is because it will help you better understand the new riddle of induction discussed by Nelson Goodman. So now let me talk to you about this next assumption. Well, actually, okay. So the next assumption, as we make as scientists, is called the simplicity assumption. So let me now explain what this assumption is by writing it down. Let me make sure you guys can see this. Okay, so here's another assumption we make as scientists. And again, we will get really into the nitty-gritty on the assumptions behind science as we move on in this course. But I'm just talking about some of these assumptions so you could better understand Hume's problem of induction as well as Nelson Goodman's new riddle of induction. Now, here's another assumption we make as scientists. Again, assumptions meaning that we just have to have faith or trust in this fact. We can't really give too much evidence for the truth of the assumption. And another assumption we make as scientists is the simplicity assumption. Now, here's the simplicity assumption. In science, when we have two competing hypotheses supported by the same exact evidence and the same amount of evidence. Okay, so let's get this straight. Let's say you have two competing hypotheses, that are supposed to explain some phenomenon. And those two hypotheses are supported by the same exact evidence and the same amount of evidence. You might be wondering what, but this happens all the time in science. We'll have more than one hypothesis that's supported by the same evidence and the same exact evidence all the time. Now, when we find ourselves in situations like this, what do we do as scientists? Well, according to Occam's razor and the simplicity assumption, we should always go with the simpler hypothesis. Why? Because the simpler hypothesis makes less assumptions or claims that require justification, that require some kind of evidence or reasons to back it up. Okay? Now, let me give you a silly example to make this point clear. Erase this. Suppose it's the end of the school day, and I'm walking back to the parking lot, and I think I parked in aisle 2B. I search aisle 2B, and I don't see my car there. So here's my evidence. Okay, my evidence is my car is not parked in aisle 2B. And how is this my evidence? I searched all of aisle 2B. I searched everywhere, far and wide, and every single car in this aisle, let's say, and I don't see my car there. Okay, so here's some evidence. Alicia's car is not parked in aisle 2B. Another way of saying this is, here's an observation that I've just made. My car is not parked in aisle 2B. And now suppose I want to come up with a hypothesis or an educated guess or a proposed reason as to why my car is not parked where I thought it was, in aisle 2B. And let's say here are the two hypotheses I come up with. Okay, so suppose based on this evidence, I come up with the following two hypotheses. The first hypothesis is I just misremembered where I parked. So I thought I parked in aisle 2B, but this memory is false. I didn't park in aisle 2B. I just misremembered where I in fact parked. Okay, that's my first hypothesis. Now let's suppose I come up with the second hypothesis. Notice, just take a pause to notice, both of these hypotheses are supported by the exact same evidence and the exact same amount of evidence, namely that my car is not parked in aisle 2B, where I remembered parking it. So same evidence supports both of these two hypotheses in the exact same amount. And now let's suppose my second hypothesis is aliens took my car. So the reason why I don't see my car in aisle 2B is because aliens came down and abducted my car. Okay? And these are the two hypotheses I have now formed based on the evidence that my car is not where I remembered parking it in aisle 2B, which, by the way, happens to me all the time. Now, notice both of these hypotheses are supported by the same exact evidence and the same exact amount of evidence. So the evidence cannot help us distinguish which hypothesis is more likely to be correct than the other, right? Because again, the same evidence supports both the hypotheses, just namely my car, I don't observe my car where I thought I had parked it in aisle 2B. Now, given that both of these hypotheses are supported by the same exact evidence and the same exact amount of evidence, I can ask myself, which hypothesis should I go with and on what grounds? So now maybe pause the video and you can think to yourself, which hypothesis seems more plausible and why? Like for what reasons? Okay, Now, I hope what you all thought to yourself is the hypothesis that seems more plausible, more likely to be true, is the first one. That I just misremembered where I parked my car, right? That's why I don't see it in 2B. Alicia's being a scatterbrained again, and she just doesn't remember where she parked. Okay. So most of us would agree that we would go with this hypothesis. But again, notice both of these hypotheses are supported by the same evidence and the same amount of evidence. And so why do we all seem to agree on going with hypothesis 1 over hypothesis 2? Well, part of the reason is due to the simplicity assumption behind science. So again, scientists just brutally assume this such that they can actually do science at all, right? If they weren't able to assume this assumption of simplicity, then we would have a really hard time finding evidence that illustrates why hypothesis 1 is more plausible than 2, given that the evidence is the exact same for both in this case. I know it's a silly example, but it's silly so you can kind of remember it. Okay, now what do I mean by simplicity? Well, as I just had written on the board, we should always go with the simpler hypothesis. So when you have two competing hypotheses supported by the same evidence and the same exact amount of evidence, which hypothesis do you go with? You should always go with the simpler hypothesis, in which case, hypothesis 1. And why? Because the more complex hypothesis, which is hypothesis 2, makes more claims that need to be substantiated, that need to be proven with evidence. So now let's look at what some of these extra claims hypothesis 2 is making that makes it a more complicated and therefore less likely to be true hypothesis about where my car is parked. So hypothesis 2 is aliens took my car. In order for this hypothesis to be true, notice all these claims that need to also be true and supported by evidence. Aliens exist. So other intelligent life exists. That they can somehow travel to the Earth. So aliens can contact Earth, that they have a way for abducting my car, that they even care about taking my car away, that they're interested in my car in the first place, that they can abduct my car without anyone on campus noticing, etc., etc., etc. These are all the extra assumptions involved in hypothesis 2 that need further evidence or justification in order for hypothesis 2 to be convincing. But now notice we don't have that kind of justification. We don't really have total proof of whether other intelligent life exists or not. We have no evidence for sure that other life can contact the Earth. And we definitely have zero evidence that, aliens or other intelligent life are somehow interested in taking my car. And so now notice hypothesis 2 is the more complex hypothesis because it makes more claims or assumptions or has more premises in the argument that require further justification. Whereas this hypothesis 1, there are no extra claims being made that require justification. All it's saying is, okay, the reason why my car is not in aisle 2, which I thought, is because I had a lapse in memory. I thought I parked in aisle 2, but actually I parked in aisle 2 yesterday. And now what's going on wrong is just my memory and the fact that I'm getting mixed up. This hypothesis doesn't make very many extra assumptions that require justification. The only, I guess, extra assumption or claim it makes is that maybe Alicia's a forgetful person, but that happens to be true. And at the very least, notice that assumption is way, way less than the assumptions we have to make for hypothesis 2. And so, again, just to remind you, the simplicity assumption behind science, sometimes called Occam's razor, is when you have two competing theories, two competing hypotheses that are supported by the same exact evidence and the same amount of that evidence, that we should always go with the simpler one, because the simpler hypothesis makes less claims or has less, premises, or makes less, assumptions that require evidence or justification. So, given that I have no evidence or justifications that aliens exist and they can contact Earth and they're interested in my car and they can take my car without other noticing, um, because I don't have any evidence for these extra kind of claims embedded in hypothesis 2, I will go with hypothesis 1. I will see that hypothesis 1 is the hypothesis that's more likely to be true, that I just straight up misremembered where I parked. Okay? And again, it's because it just makes less assumptions. The only assumption being made in hypothesis 1 is that I can have a lapse in memory, which of course happens all the time. That's not the case for the second hypothesis. So now you know another assumption behind science. When you have two competing scientific hypotheses that are supported by the same exact amount of evidence and the same evidence itself, you should always go with the simpler one, because the simpler hypothesis makes less claims or assumptions that require further justification. In a way, you can think of this simplicity assumption as a nice way to combat the conspiracy theorist. So the conspiracy theorist always thinks that, like, the real cause of, let's say, something going on socially or politically is some grand master scheme put in place by some, put in place, yeah. Sorry, my computer kind of just froze out there. So in a way, this simplicity assumption in science can help you argue against the conspiracy theorists, right? Because you and the conspiracy theorists, you come to different hypotheses given the same evidence. So, like, the conspiracy theorists, notices 9/11 happens and thinks it's an inside job. The other person, notices 9/11 happens and, thinks that it has to do with the fact that the United States was targeted by certain terrorist organizations. And now you want to figure out what's the correct hypothesis. Well, now notice the conspiracy theorists. They have a lot of extra kind of claims they make in their argument that require justification, even though they're looking at the exact same evidence. So they have to think to themselves, well, first of all, we're capable, the United States government is smart enough to make an inside job like this, that they have the desire to topple the World Trade Center, that they had some grand reason to do so, et cetera, et cetera. Okay, these are further claims that require justification, and until we have justification for those further claims, we should go with the simpler hypothesis supported by the same evidence that it was an act of terror induced by, some other, Osama bin Laden and others involved. Okay. So now we've just talked about another assumption behind science called simplicity. When you have two competing hypotheses supported by the exact same amount of evidence, you should always go with the simpler hypothesis, meaning the one that makes less assumptions or makes less extra claims about the world that require further justification or evidence. You should always go with that hypothesis because it's just more likely to be true. Now, again, notice in the alien case, definitely hypothesis one is more likely to be true because all of these other assumptions or claims that are being made to generate hypothesis two, I don't have any evidence or justification for. And so this hypothesis is weaker than this one, okay? That is the simplicity assumption. Now I'm going to pause the video and talk about the new riddle of induction in the next video. Sorry for the little glitch.